Now, a smooth sphere moves on a horizontal table. It strikes an identical sphere or rests on the table. The latter is a distance y from the vertical cushion. Okay, so here's our vertical cushion here. Okay, and then we have two spheres. There's one. There's two. Okay. Now, the first one, the latter's cushion distance y, so it's distance y from the vertical cushion. Okay, and then the impact is along the line set is normal to the cushion. So normal to the cushion means the cushion just hits normally, like, you know, just normal collision stuff. The impact is along the line set is normal to the cushion. The next collision between the spheres takes place at distance d from the cushion. So there'll be a secondary collision, which will be down here. And you're imagining that they're both closing in on the cushion. Like, you imagine that the first one hits it, rebounds back, and then they both have another collision somewhere around here. Okay, closer to the cushion. Has to be closer to the cushion by pure logic. And that's the distance d. Okay? Now, so the story is A hits B a distance y from the board. B rebounds off the wall. This is A, B. B hits the wall, rebounds, and then collides with A at distance d from the wall. Okay, let's go for our first collision. And let's get our PCM going on here. Okay, PCM being M1U1 plus M2U2 equals M1V1 plus M2V2. So we're going to have M times U plus M times 0, because B is not moving, equals MV1 plus MV2. V1 plus V2 equals U. Next thing we're going to do is go and try Newton's experimental law along the y-axis. We're going to get is V1 minus V2 minus E into U1 minus U2. And then we're going to get V1 minus V2, and we know that U1 is U because it's moving at U and the other one's moving at 0. Then after collision it's moving at V1, that one's moving at V2. So it's going to be minus EU. Okay, bring them both down together and add them both directly downwards. Okay, so I'll just bring them over here. So add them both directly downwards, and we're going to get 2V1 equals U minus EU. V1 is going to go U into 1 minus E all over 2. So that's what V1 is. Now I'm going to manipulate this equation for V2, so I'm going to get minus V1 plus V2 equals plus EU. V1 plus V2 equals U. 2V2 ends up to be U into 1 plus E. V2 is U into 1 plus E all over 2. Now look at these equations, lads. No matter what the value is of E, V1, remember E is in between 0 to 1. V1 at best stops, it never goes left. V1 is always travelling to the right. V2 has to travel to the right no matter what, because it's 1 plus E. Okay, and E always has a positive value between 0 and 1. Now that that's done, we're now on to the second collision, where B is hitting the cushion. Okay? And when you hit a cushion, your velocity equals minus E times your initial velocity. So your rebound velocity, which is going to be going to the left, is going to be minus E. Now, it says that the cushion and the ball have the same amount, don't they? Yeah, E is the sphere and the cushion, so E is the same no matter what the two objects are. So it's going to be minus E times, now what's V2? So it's U into 1 plus E all over 2. So it's going to be minus EU into 1 plus E all over 2. That's its velocity on the way back. Okay? Now, next thing we got to worry about is the time taken for, it's technically the third collision, isn't it? Or the second collision between particles A and B. So you're going to say time taken for third collision to occur. Is that what it's asked me to do?
Distance.
Yeah. So D. So technically what we're doing is this. Drawing pictures for me makes it easy. D. Yeah? Now, what we're going to do here is time taken for the third collision to occur. Okay? Now, what distance? The other collision took place at, okay, let me see. Okay, so this one took a distance of y, yeah? That went to travel a distance of y, and then it came back, okay? So the first time is going to be y over v2, okay? So we're going to have y over v2. Is going to be the time it took to hit the cushion. This one here represents time to hit cushion. Are you happy with that? Okay. The next one is going to be D all divided by. Now I'm going to write down EV2. Do you know what I mean by EV2? The rebound velocity. This here is the rebound velocity. I can just write it in if you want. Just rebound. I can write down rebound velocity. Okay. Now, do you notice that I don't care if it's positive or negative? I'm just more concerned about the speed. So more rebound speed than anything. Okay. Now, what's the rebound speed again? We got it a second ago. EU 1 plus E all over 2. Don't mind the minus though, it's a distance time question. Like if I said I cover 10 meters with a velocity of minus 5, it's still 2 seconds. It doesn't matter that it's 2 meters to the left or 2 meters to the right. So that's why we're going to take the positive version of this. So it's going to be EU 1 plus E over 2. Okay? EU 1 plus E all over 2. Now, this time taken for the second collision to occur, this here is the story of what? This one here is the story of particle B. Do you understand? It's time to hit the cushion. It's time to rebound back to hit A. Now we need the story of A. The story of A was that when it hit B, it was a distance y away. Yeah? And then, A hit B, okay, a distance y away from the cushion. Then B comes back out to meet A distance d from the cushion. So A has in fact travelled the distance y minus d. So the time for A equals the time for B. So y minus d divided by the speed of A. The speed of A was u over 2, 1 minus e. And now we have an equation. Which letter do we need to isolate? D. We need to isolate D. So here we go. Hard algebra coming up. What's phi2 again? Phi2? I think it's u 1 plus e all over 2. There it is there. Okay, let's try this out. Okay, multiply everything by 2. Or bring the 2's to the top. Okay, so we're going to get 2y minus 2d equals 2y plus 2d all over EU 1 plus e. This one here is u 1 plus e. Now what I was thinking is if I added e here, and an E here, these now have the same denominator. And now I have U into 1 minus E. Cancel the U's. Okay? And now what I'm going to be left with is, I'm going to be left with 2y minus 2d equals 2ye all over e into 1 plus e. Oh sorry, that's the one denominator now. Plus 2d. Cross multiply. 2, might as well multiply that out, won't we? E plus e squared, yeah? And did I already multiply that by 1 minus e? No, I haven't. Okay? Cross multiply. 2ye plus 2ye squared minus 2de minus 2de squared equals 2ye minus 2ye squared plus 2d minus 2de minus 2de with minus 2de 2ye and 2ye. Anything with d goes to the right, anything with y goes to the left, so we're going to get 2ye squared plus 2ye squared 2de squared plus 2d. 2's cancel. And then we should get a d into e squared plus 1 equals 2ye squared. D, therefore, am I correct with this? D equals 2ye squared all over e squared plus 1. Okay guys, next part then, interpret the result when e equals 1. When e equals 1, e equals 1, d equals 2y over 2, d equals y. Huh?
Does that mean the first particle stops when it hits the second?
Yeah. So, and also, when e equals 1, this is what I said earlier, phi1 equals 0. So, interpretation is, after the first collision, particle A stops flat, particle B bounces off the wall and comes all the way back to hit with A. And that's your interpretation.